Good day, grade 9 learners. Right, we are going to deal with Pythagoras Theorem, or we are continuing with the Pythagoras Theorem. Right, in this case, the answer that we are going to come up with is a number that has got a factor which is not a perfect square. Right, so in this case, if we are having such a number that has got a factor which is not a perfect square, it means we must leave our answer in Z form. Right, now before we look at an example whereby we are to leave the answer in Z form, let me go back to the definition of Pythagoras theorem. Now, Pythagoras theorem, if you still remember, it states that the square of the hypotenuse is equals to the sum of squares of the perpendicular sides. In other words, our hypotenuse is the side which is opposite right angle, or it is the side which is opposite 90-degree angle, right? Which means for us to make use of this Pythagoras theorem, we are looking at a triangle. This triangle is a right-angled triangle. That's what we dealt with in the previous lesson. So we are continuing with the same definition for Pythagoras theorem. However, the only change here that I did is to make use of Pythagoras hypotenuse side, right? Then the hypotenuse side, if you still remember, it is the side which is opposite 90 degrees, and this side is the longest side in a right-angled triangle. So the hypotenuse side is opposite 90 degrees, or it's opposite right-angle triangle. Sorry, it's opposite the right angle, and it is the longest side of a right-angled triangle. Right. Then the other two sides are perpendicular to each other, meaning they are right angle to each other. They are 90 degrees to each other. So all those terms can be used. Perpendicular means right angle. It means there is 90-degree angle. All right. So the triangle is a right-angled triangle. Now, when it comes to said, I've just tried to define it or describe it. It is a number. This number is a non-perfect square, which means it is not a perfect square. And this number, which is not a perfect square, is under a radical sign, right? Instead of calling it the radical sign, we can call it the square root. So it's under a square root. So I've got an example here, two examples of numbers. Right, so we are going to express 18, square root of 18 and square root of 320 in Z form. We are going to express a square root of 18 and square root of 320 in Z form. Now, in order for us to express square root of 18 in Z form, right, what I just do here is to find a perfect square which is a factor of 18, right? So expressing 18 as a product of its perfect square and the non-perfect square, it is 9 times what? 2. 9 is a perfect square. 2 is not a perfect square. So when you multiply 9 times 2, you come up with what? 18. So square root of 18 is equals to the square root of 9 times 2. Everything is under the same radical sign. Our radical sign in this case is the square root sign. Then from there, since we are multiplying, I can distribute the square root sign to the factors. Please note this is only true. We can distribute the square root sign whenever we are multiplying or whenever we are dividing. It's only in those two cases where we can distribute the radical sign. That is when you are multiplying factors or we are dividing numbers, right? We can distribute the radical sign. Now, so I've just distributed the radical sign to square root of 9 times square root of 2. Then square root of 9, we can simplify it to 3, then times square root of 2. Remember, 2 is not a perfect square. Right. So then from there, I then simplified it to 3 square root of 2, which means that square root of 18 is equals to 3 square root of 2. So this 3 square root of 2 is now in said form. Now, this said form is normally used whenever we want to have an exact value, right? Which means we are not supposed to estimate it or to round it off. So it is an exact what? Value. However, the number that we have here, we are having a number or a factor which is still under the square root sign. Why? Because it is not a perfect square. So square root of 18, the exact value for square root of 18 is equals to 3 root of 2. That's in short, which is square root of 18 is equals to 3 square root of 2. Then we do the same for 380. The square root of 380 on its own is not a perfect square, but it has got a factor which is a perfect square, and the other factor is not a perfect square. So the perfect square that is in 320 is 64. So we can express 320 by using factors of 64 multiplied by 5. All right. Again, we can simplify this part by distributing the square root sign, which means it is equals to square root of 64 multiplied by square root of 5. Remember what I said previously, that whenever we are multiplying or whenever we are dividing numbers, we can distribute the square root sign or we can distribute the radical sign, right? We cannot distribute the radical sign or the square root sign whenever we are adding or subtracting numbers. Never ever distribute it. We can only distribute when you are multiplying and or what? Dividing. Then, so I distributed the square root sign to square root of 64 multiplied by square root of 5. Then I simplify this perfect square 64, which means we come up with 8 multiplied by square root of 5. Then we simplify by removing the multiplication sign, which simply means it's 8 square root of 5. This 8 square root of 5 is exactly the same as 8 multiplied by square root of 5. So we simplify to that point. So it now means that rewriting 300 square root of 320 in Z form, it is equals to 8 square root of 5. So these are examples of numbers that are expressed in Z form. Now, coming on to today's problem now. We are going to use this so that we can calculate the answer or the length of a side. So, in the example that is given here, it says given triangle PQR with PQ equals to 8 centimeters, QR equals to 20 centimeters, and angle Q is equals to 90 degrees. All right? Determine PR. Determine PR. So in that case, in this case here, or in the example that we are given there, we can see there that, let me just enter the degree sign. Right, I was saying in the question that is given in this case here, right, it's like we are looking at a triangle. This triangle is a right-angled triangle. Why are we saying it's right-angled triangle? The angle Q is 90 degrees, right? Then it is a triangle which is a right-angled triangle. So this symbol, a square like on vertex Q, is the symbol which shows that it is 90 degrees, or it is perpendicular, or it is, we are having a right angle here. The right angle is formed by which sides? PQ and QR. So these two sides, PQ and QR, are perpendicular to each other. They are 90 degrees to each other. They are at right angle to each other. So all those terms can be used. Right angle, perpendicular, or 90 degrees. So which means a right angle triangle. So in this case, since it is a right angle triangle, we can apply or we can use Pythagoras theorem to find the length of one of the side. Now, it is only possible for us to make use of Pythagoras theorem to find or to calculate the length of one of the sides if two sides are given. That's when we can make use of Pythagoras theorem. Two sides are given, we are to calculate one side, all right? Now, so in this case, in our diagram, the information was not put on the diagram, so we can put that information there, right? So allow me to put the information by using a different color, right? I'm not saying you are supposed to use a red pen whenever you are calculating, whenever you are doing calculations, just use your blue pen, right? Now, so in this case, we are informed there that side PQ is 8 centimeters. So it's 8 centimeters. That's PQ. Then we have side QR, which is 20 centimeters. Right? I'm putting the information so that I can see my diagram clearly. And which side am I supposed to be calculating? I'm supposed to be calculating which side? PR, right? Sorry. Right, I'm supposed to calculate what? PR. So normally I just make use of a question mark, all right? So that's the side that I want to calculate. So I'm just putting the information because it was not there on the diagram. Why am I putting it on the diagram? It's for me to see my diagram clearly, right? So that I won't get confused. And secondly, it's for me to identify the side that is known and the side that I'm supposed to calculate. Right. So looking at the diagram, the triangle PQR, PQ is given, QR is also given. I am to find PR. Now, the side that I am supposed to find here, what type of a side is it? Is it a side which is perpendicular to the other side? Or is it a side which is opposite 90 degrees, which we normally call hypotenuse, right? Now, looking at the diagram, we can see here that PR is opposite right angle, is opposite 90-degree angle. So it means this is the hypotenuse side, which means it is the longest side. So according to Pythagoras theorem now, I'm now going to solve the problem now. So according to Pythagoras theorem says what? The hypotenuse side is equals to sum of it is equals to the sum of the sum of squares. Right, it's sum of squares of the two perpendicular sides. Right? So it means we are going to find the squares of the other two sides which are perpendicular to each other. Right? So the sum of those two squares of the sides which are perpendicular to each other gives us or is equals to the sorry, I left out important information here. Square of the hypotenuse So we are saying the square of hypotenuse side is equal to the sum of squares of the two perpendicular sides. At times we just say the square of the two other sides. So these two other sides are perpendicular to each other. This is the definition of Pythagoras theorem. So the square of hypotenuse side is equal to the sum of squares of the two perpendicular sides. Now, then making use of the vertices that are provided in my triangle, it means we are just going to say it is what? It is, then we have our hypotenuse side, which is PR. Right, our PR is squared. So PR squared is equals to, then we say it is equals to, what are these two sides that are perpendicular to each other? It's PQ squared, PQ squared here. Then we add it to, remember sum simply means add. Add it to QR. So our QR is also squared. Right? So definition of Pythagoras theorem says hypotenuse side is equal to the sum of squares of the two other sides. These two other sides are perpendicular, remember. So the two sides that are perpendicular to each other, that are right angle to each other, that are 90 degrees to each other, it's PQ and QR. So we added them here. Then from there, I will then substitute my sides. So the sides that are given, we are given PQ. So I'm going to substitute PQ, which is 8 centimeters. Right? Then my 8 centimeter side is squared. I will square it. Remember, I'm just substituting. Then we add the other side that we are squaring QR. QR is also provided. That's 20 centimeters. Then from there, I'm going to simplify now, which means 8 squared is 64. I'm leaving out the unit, right? But our all measurements are in centimeters. That's fine, right? Then 20 centimeters squared, we have 400. Then from there, simplifying 64 plus 400, we are going to come up with 464. Now, so what it now means is we are saying PR squared is equals to 464. That's what it means, right? So which means in this case now, we are going to put, I'm just rewriting the the side squared or our hypotenuse squared, which is equals to 464. Now, in order for me to solve this problem, it means I must find the length of PR. So I must get rid of the square on PR squared. So for me to get rid of the square on side PR, I'm going to put square root sign, which means I'm going to remove the square by putting a square root. So I'm going to put the square root sign on the two numbers. I'll put the square root sign on the two numbers that we have on either side of the equal sign. So I'm going to get rid of the square by putting square root on both sides. So the square root of PR squared is equals to the square of what? The square root of 464. So whenever I'm putting a square root on a value or on a number, we are always coming up with two answers. It's either it's positive or it's negative. This must always be remembered. Whenever you are putting a square root number on, whenever you're putting a square root on a number or on a value, we are always coming up with two answers. It's either it's positive or it's negative. That must always be remembered. Right, so from there, I'm now going to remove the what? The square root. So I can only remove the square by putting a square root or by finding its square root. That's how we can remove the square. So, square root of PR squared. The square root removes the square, which means we are going to come up with PR, which is now equals to. Remember I said there are two answers there. So we can say the smaller one is minus square root of 464, or it's positive square root of 464. These are our two answers. Remember, whenever you square a negative number, it becomes positive. If you square a positive number, it will still remain a positive number. Right. So from this case now, our 464 is not a perfect square, but it is made up of a perfect square, a factor which is a perfect square, and the other factor which is not a perfect square, right? So, how do we do it now? Allow me to just do a side calculation here so that we can express 464 as a product of its perfect square and a non-perfect square. So it means we are going to write the square root of 664. We factorize it and write it as a product of its factors. One of it is a perfect square, the other one a non-perfect square, right? At times you may find out that the number might not be having a perfect square. right? So if it doesn't have a factor which is a perfect square, then it means that's your final answer. But if there is a perfect square in that particular number, then you just have to factor it out and simplify it, right? So in this case, we are looking at 464, which is then equals to, I'm factorizing it. My factors are going to be perfect squares and the other one in the form of a non-perfect square. So the perfect square that we have in 465, what is that perfect square that we have, right? The perfect square that we have as a factor in 464 is what? It's 16. So it is 16 multiplied by 29, right? That's the number. So since we are multiplying, right, the factors, so it means we can distribute the radical sign, which means in this case the radical sign is what? Squared sign. So we can distribute what? The squared sign, which means it becomes 16. I'll put the squared sign later, multiplied by square root of 29. So it is square root of, sorry, my screen moved. Right, so it's the square root of 16 times square root of 29. Then from there, I'll distribute, sorry, I'm now going to simplify my numbers. Square root of 16 is 4. Then multiplied by square root of 29. Remember, 29 is not a perfect square. It is a prime what? Number. It is a prime factor. It's not a perfect square. So it becomes 4 multiplied by what? Square root of 29. Then from there, I must further simplify it. Since I've got multiplication sign in, I must simplify that, which means it is going to be 4 square root of 29. It becomes 4 square root of 29. That's converting or changing square root of 464 in Z form. It becomes 4 square root of 29. So it now means then that my side PR is equals to, it is equals to, it's either negative 4 square root of 29, I will put the square root later, or it's positive. Since a number, whenever a number is positive, we may leave out the positive sign, right? So I'm leaving the positive sign, which is 4 square root of 29. Remember, I am now taking my answer from the side calculation that I did here on my right hand side. So it means it's negative 4 root of 29, or it's positive 4 square root of 29. So since we are dealing with length of side, length of sides will never be negative. It will always be positive. So it means my length for PR is equals to what? It is equals to 4 square root of 29. So this answer that we have is an answer which is written in said form. Remember we said said form is a number that has got a square root what? Sign, right? It has got a square root sign. Why? Because the factor, or that factor, is not a perfect square. So this is now the answer, which means PR is equals to 4 square root of 29 centimeters long. That's our final answer in said what form.